Hello everyone. Today we're looking at scale models and scale diagrams. In question number 1, a model for an Airbus 380 uses a scale of 1 to 144 for its model. Based on the diagram to the right, we need to determine the model's wingspan, length, and height. With this ratio, the 1 represents the model, and 144 represents the actual plane. Let's start by determining the length of the model's wingspan. So given the actual plane has a width of 79.8 meters, we can start with 79.8 meters. And the key thing with this question is to remember that multiplying by a number greater than 1 amounts to an enlargement, and multiplying by a number between 0 and 1 amounts to a reduction. So if we're looking to reduce the wingspan to a model dimension, we should probably multiply by a number between 0 and 1. So it wouldn't make sense to multiply this number by 144 because we'd end up with something quite a bit larger than 80 meters. We should probably multiply by 1 over 144. So basically we're dividing 79.8 by 144 and we get a result of 0.554 meters. And if we remember that 1 meter equals 100 centimeters, we can convert this number into a number of centimeters. So we need to divide this number by 100, or basically move this decimal to the right twice. So that means the model has a 55.4 centimeter wingspan. Next we need to figure out the model's length. So starting with 73 meters, we again multiply by 1 over 144, and we get a result of 0.507 meters, which again we can convert to centimeters by dividing by 100, and we see it's 50.7 centimeters. As for the height from the diagram of the actual plane is 24.1 meters. We need to divide that number by 144, and we get a result of 0.167 meters, which in centimeters would be 16.7. In question number 2, the front and side elevation of a pipe is shown on the paper. A scale of 1 to 8 was used to draw the elevations. Measure the drawing and then determine each of the following dimensions for the actual pipe. So we need the outer diameter, inner diameter, wall thickness, and length. Let's start by determining the outer diameter. So I've lined up the 0 here, and it looks like this measurement is about 6.1 centimeters. So you will likely measure this to be something different than I've done here, depending on the size of screen you're watching this on, or how your printer scaled this page if you managed to print it. Again, I would encourage you to use your own measured values throughout this video and adapt your numbers accordingly. So our drawing has a measurement of 6.1 centimeters. The scale is 1 to 8, so 1 is the model and 8 is the original. So we need to multiply the outer diameter of the pipe as measured in the diagram by 8 over 1 to get the true outer diameter of the actual pipe. So we get 48.8 centimeters. Now for the inner diameter, so again we're going to line up the 0 mark. From here to here looks to be about 5.25 centimeters. So we can record a measurement of 5.25 centimeters for our diagram. Again, we need to multiply by 8 over 1, and we get a result of 42 centimeters. Next, we can measure the thickness of the pipe directly, or we can subtract the inner from the outer diameter and divide by 2. Based on the direct measurement, it looks like we're getting an answer of 0.4 centimeters, going from here to here. We need to multiply that by 8 over 1 to determine the true wall thickness of the pipe. 0.4 times 8 works out to be 3.2 centimeters, which is fairly close to the result we would have gotten by subtracting the inner from the outer diameter and dividing by 2. If we did it that way, we would get 3.4 centimeters. So they're fairly close, but there's always going to be some uncertainty with any measurement. And the last thing we need is the length. So again, we line up the 0 mark, and it looks like we get a result of 11.2 centimeters. So in the drawing, it's 11.2 centimeters. We need to multiply that by 8, and we get a result of 89.6 centimeters for the length of the actual pipe. In question number 3, we need to determine the value of x and y in these two similar tetrahedra. So it looks like we have 2 out of 2 for this corresponding length. So we could determine a scale factor to get from the smaller one to the larger one by going scale factor equals model over original. Just for consistency, maybe we'll call this one the model and this one the original. So the model divided by the original dimension, we would have 50 millimeter divided by 10.25 millimeter, which gives us 4.878 and some other digits. I'm going to keep this value unrounded and available in my calculator so I can calculate x and y. So the corresponding length for x is this one, so we need to do an enlargement for that measurement to get to x. So that means we need to multiply by 4.878. So we start with 9.15 millimeters and multiply it by 4.878, and we get a result for x of 44.63 millimeters. Now if we're going to go the opposite direction, the corresponding length for y is there, and we'd need to scale down the length of 8.4 millimeters. So if we are looking to scale down 8.4 millimeters, we need to divide by 4.878. Starting with 8.40 millimeters, we divide by 4.878, and we get a length for y of 1.72 millimeters. So in general, if two 3D objects are similar and the scale factor for the two objects is k, then k equals the linear measurement of the scale model divided by the corresponding linear measurement of the original object. To determine the dimensions of a scale model given a scale factor of k, all of the object's dimensions must be multiplied by k. So the linear measurement of the model is equal to k times the corresponding linear measurement of the original. If k is between 0 and 1, then the scale model is smaller than the original object, and if k is greater than 1, then the scale model is larger than the original object. In question number 4, we have a scale model of a car that's 1 to 25. A diagram of the model along with the measurements is shown below, so we need to determine the dimensions of the actual car. So we can start with the height. The height in the model is 75 millimeters. We need to enlarge that to get to the actual car dimensions, so we should probably multiply by a number greater than 1. So what we do is take 75 millimeters and multiply it by 25 over 1, and we get a result of 1875 millimeters. Now we should probably convert that to an answer in meters, knowing that 1 meter equals 1,000 millimeters. 1,875 millimeters is equivalent to 1.875 meters. Next we can look at the width. The width of the model is 60 millimeters. Again, we need to multiply by 25 over 1 to enlarge it to the actual dimensions, and we get a result of 1,500 millimeters, which we can convert to a result of 1.5 meters. And finally, for the length of the car, the length of the model is 140 millimeters. We need to multiply that again by 25 over 1, and we get a result of 3,500 millimeters, which in a more convenient measurement would be 3.5 meters. So that's it for me for today. I'll get you to do this question, and I'll see you next time.